put all those rock cages and then put the gunite on it and made those channels. How is that, what could happen if we have that kind of water coming through the river again with that channeling we did?
You hope it holds, but really when you're dealing with Mother Nature, about anything that you do may or may not work. You hope it does. It could happen again.
But isn't the natural flow of water, I mean, like you said, what we've done is build our roads and our bridges and stuff at
In our
all.
houses and farms and everything
So is
else.
that kind of doing the same thing in the upper canyon?
Channelizing the water, we've
Yeah.
definitely done that. Yeah, we're trying to put it in one spot and we do get a big flow. It's gonna try to go back out into the original, the historical floodplain, and that's exactly what it did in 2008.
It'll find a way.
Yeah.
You know, we've had some natural crevices in our property that probably maybe happened back in 1941, I don't know what caused them, because we haven't really seen any water for several years in them. And so we had been putting some of our tree, branches and things in there. But when the Little Bear fire came, it burned it all out, and so it's almost like, isn't that hazard to be throwing that up on that?
Yes and no. I see where you're coming from with that, and I think to go back, especially after the fire, is probably real important to do something like that again, and especially, there's probably a lot of the bigger stuff that probably burn the bark off, but the actual tree part's still there. Tying those things in is probably not gonna burn the second time, and it is gonna hold the sediment back, and you're gonna start terracing that a little bit more, and I can see what you're saying. I'm just putting fuel down for the next time. So maybe something like that, you want to go to the rock and wire, something that, if you feel like I don't want to go back with brush, I don't want anything that could burn, go back to something else that is going to help hold. Even using something as simple, I know the county was giving out, the wattle, something like that was, yeah, they'll burn too, but it's not near as much.
I mean, I don't know what all the birds, it's pretty good bird, but yeah, that would help a lot. I had called to get some and I never, because there is a problem, well, not specifically, but in our property where the water flows through. And I never got a response, well, we don't have a grant money to get those. They were getting them there at one time. You got some, maybe I didn't pursue.
Yeah, the Upper Hondo Soil Water Conservation District has the wattles for them.
And they still do?
And they still do. So I don't have that number, but you can certainly Google it, or they're in Capitan, so that phone number is there. But the Upper Hondo Soil Water Conservation District still does that program for the county, and there are still wattles available to be able to do that. And I know, post Little Bear Fire, we worked with NRCS on doing some catchment tanks specifically for in the higher country where we knew when the water was coming down to catch that sediment and hopefully keep it out of the stream beds. So because it just kept carrying more and more sediment with it. So those are some of the things that John's team helped us identify, some kind of strategic spots. And, we were able to do, and the goal of those sediment tanks is that within a couple of years, you're not gonna have a tank there anymore. It's gonna be full of the sediment, but it's keeping that sediment from going downstream that is important to all of the downstream users and everybody, because they don't want it. So, it's one of those things. Well, thanks very much, guys, and that'll be are going to really kind of give you some idea as to what a watershed is, some of the things that other places in the state are doing to improve the quality of the health of the watershed. We have Dr. Brent Racher with us, and he is with Racher Resource Management, and he's also president of the New Mexico Forest Industries Association. And joining him is Laura McCarthy, and she is with the Nature Conservancy. And both of them have been very active in some really kind of exciting things. One of the things that you'll find as you work in this industry is we are state faces the same exact problems, and there are some really very smart people out there coming up with some very exciting ways to accomplish the goals, and I think we can learn a lot from them. So Brent and Laura.
Thank you, Laura. The other Laura. Is this working?
No.
So I am Brent Rager, and I'm here representing statewide industry association, trade association, the New Mexico Forest Industry Association. And the Forest Industry Association is made up of the businesses in the state, people in the woods doing thinning, logging, manufacturers, kelp manufacturers, compost manufacturers, forestry consultants. We have a pretty broad range because we have relatively a small industry in the state. And our motto is, behind every healthy forest is a healthy forest industry. There needs to be people doing things because of where we're at.
I'm with the Nature Conservancy. We are a large, global, non-governmental organization that works on conservation issues. Our approach is a little unique in that we pursue pragmatic and non-confrontational approaches to conservation challenges.
So we're going to talk about some stuff today that is ongoing in the state and in other places. And we're going to focus on some areas that are very similar to this Ruidoso area, to Lincoln County, to Otero County. We've seen similar things all over the West, over much of New Mexico. And this is a picture of the Los Conchas fire, which in 2011 ended up being the largest fire in the state. 2012, we broke that record again. I think the Los Conchas fire was 150-something thousand acres. And this fire really put us in a place where we said, all right, we're definitely not doing enough. At one point, this fire burned 40,000 acres in a day. And it set everybody back a little bit and said, we're not acting at the scale that Mother Nature is.
In fact, you can see combustion taking place 1,000 feet off the ground. This is the image none of you will see.
But this is the image we've all probably seen.
And this, part of why we're worried about it is Las Conchas fire in that 40,000 acre spread in one day caused this kind of damage where scientists who are experts in fire ecology call this a moonscape and unprecedented. And after Las Conchas fire, we had 66,000 acres that looked more or less like this, with nothing live left on it, no soil to speak of, and no seed sources for a new forest to regenerate. Okay. So, from a water perspective, what we're worried about is when it rains on that kind of a landscape. And do we have the video?
Yes.
Okay, great. Well, I'm gonna,
You want me to
let's
go
go
to it?
forward to that and show it, so, and then I can talk about the, so, this image was taken about 6 weeks after Las Conchas fire, and
This is the Dixon apple orchard. A lot of people have heard about this on TV. The orchard itself did not burn. This is the debris and flooding, the debris flow flooding that came down.
yeah, there you can see the orchard. This was after 2 afternoons of thunderstorms, neither of them remarkable, 1.5 inches in 8 hours, so very normal, minor kind of rainstorms.
Oh, my.
So the image on the lower left, that building, is the Dixon Conference Center. So that was in the path of the water that you just saw. And right here is where that canyon comes into the Rio Grande. And this is a sediment plug that the Army Corps of Engineers estimates is 70 feet deep. So you essentially had this mass movement of soil and debris and ash and rock out of the mountains down into the river, which, you know, the Rio Grande happens to carry the San Juan Chama water. It's essentially water for half of our state's population.
And this is Cochise Lake, which caught all that water, is the first lake in the Rio Grande that caught all that debris. And, you know, Laura mentioned that this water source is water for over half of our population. And this is what it looked like. On the left is a water sample prior to the flooding. On the right is the water sample afterward. City of Albuquerque actually quit pulling water from the Rio Grande. They built this nice new shiny water treatment facility, and they didn't want this going through it. They said technically they could have cleaned it up, but it was just too expensive. So they chose not to for 6 weeks. Went to groundwater pumping and during the middle of summer and stopped using the water. So, you know, there is significance to that.
This is important to a lot of us because we're foresters. We've been working on the forest and fire issues for a long time, and it wasn't until we realized the impact that large-scale fires were starting to have on New Mexico's water supply that people started to really get interested in what could be done. There's also a cost factor. So the University of New Mexico Economics Department did a study for this project where they looked at a full cost accounting of Las Conchas fire. Things like devaluation of property next to burned areas, which I imagine might resonate for some of you. Businesses closed because of an extended fire season in your area. Lost tourism because of media images of wildfire and people deciding not to come to your town. Things like evacuations and the costs that are incurred from that, hospital visits from asthma, a full range of things. So going into that study, we knew that $48 million had been spent on fire suppression. And from the UNM study, we now know that there's a range of costs with a midpoint of $246 million just for the Las Conchas fire. If we had $246 million to invest in the solution, we'd be pretty much done by now. So keep those numbers in mind.
And I'll mention that, you know, especially Dr. Jamie Shomack, that UNM's tracking this for a year 3. This full cost keeps growing. Those costs are still accruing. And they're continuing to track that. So what needs to be done is proactively managing. We've got to stop reacting to these fires. We know that. We've talked about it. You know, Laura mentioned that us in forestry know it. We've seen this coming. We've tried to do some things. We need, you know, this is an all hands on deck type of time. We need everybody to come to the game right now to scale up to where we need to be in this state. You know, we need to proactively ban a lot of these forests, and we'll talk more about that. But that's probably number 1 on the list. We need to get these forests where they don't burn in this manner, where we can manage the fire. We need to do a lot of stream restoration in areas. John talked about a lot of the degradation in gulling and you know, repairing that is part of the solution, especially after the fire. Both the stream restoration and the flood mitigation, we're not doing a real good job of handling that. You know, We have in various areas a lot of people that are doing a lot. We need to do it better because we're going to still have, we're so far behind the 8 ball, it's going to take us time to catch up. You know, we've got a long ways to go. We can catch up, but it's not going to happen overnight. And then managing fire. And that means a couple of things. You know, one of the things in particular is getting natural fire back into, getting prescribed fire back into the system. Right now, we can't let fires burn a whole lot. We can't do a lot of prescribed burning. We've got to return fire in its natural process to the forest in some places.
We did, well, I guess there are a couple things on this map to show. One of them is the area that we call the Rio Grande Waterfront. And we're talking about it in this presentation really as an example of one of the ways in which we can organize across political and social jurisdictions in order to get to a scaled up solution. So this, you're going to see this map shape a bunch of times, and I'll just orient to it that this is Albuquerque the Gray. You can see the Rio Grande. You can see up at the very top left, that's the San Juan Chama headwaters over the Colorado border. The green is National Forest, which is most of the ownership. The BLM lands are a little washed out here. They're looking kind of gray. There's sort of a purpley tone for tribal lands. And this is what we call the Rio Grande Waterfront area. So basically Belen north to the border. In this area, we estimate that currently between Forest Service and other federal agencies, about 3,000 to 5,000 acres a year are being mechanically treated, overgrown brush and trees removed. Statewide, we would estimate that it's about 10,000 to 12,000 acres. Now, when we have fires like Las Conchas, and actually the Whitewater Baldy fire also did this, growing 30,000 to 40,000 acres in one day, our scale of treatment, 10,000 acres statewide, a year is just, yeah, it's not the right scale. It's not very effective. So the rest of this talk is going to be about how to scale up and what some of the mechanisms are to get to 30,000 acres a year for the Rio Grande area or 50,000 to 100,000 acres statewide. And the model that, one of the models that we're going to talk about is a water fund. The Nature Conservancy has developed a whole set of water funds. The very first one was in Quito, Ecuador, more than a decade ago. There, the city is a population of about 2 million people. There's a water utility that was one of the ways in which individuals invested in the upstream restoration. Also, companies like Coca-Cola and a number of breweries that needed clean water for their businesses, they invested in a water fund. The water fund was managed by a board. The interest was used to pay farmers upstream in the Condor Bioreserve to alter their management practices in ways that cleaned up the water. So kind of a simple model that we thought we would test, and we've actually, it's been replicated 12 times already in Latin America. You can see the blue is Quito and the green are the mature water funds, and there are 20 more in development in 4 different countries. So we know this is a tool that is flexible in many different types of government environments. And we've tested it in Santa Fe. We did a small-scale water fund that's been functioning since 2009 and has enabled the city to co-invest and co-manage the Santa Fe watershed that supplies 30% of Santa Fe's water. Also, Denver has an agreement between the Forest Service and the Denver Water Board that's putting $16.5 million of Denver Water Board money into restoration of national forest. And in Flagstaff, the residents voted on a $10 million bond that's specifically to restore 2 tracts of national forest land that are very essential to Flagstaff's water supply. So 3 different kind of models of water fund to consider.
So as part of the Rio Grande Water Fund, we've been working for a little over a year on this. And some of the first questions were, you know, what needs to be done, where do we need to do it? With this map of New Mexico, and the colors are just, they're off. Is there a way to adjust that? Does anybody know? You know.
Trust us, it's prettier.
Well, I'm looking at the colors here. You see the boundaries of the Rio Grande Water Fund area, but we actually went and did this statewide. So there are plans out there. We have the State Forest and Watershed Health Plan. We've got regional and state water plans. We've got a lot of information out there. But in prioritizing, we said, all right, you know, where are these values that we want to go to protect people's water sources, to protect, you know, all these things. And as part of a comprehensive plan, we kind of mapped out in a very short version, and with everything, it came out to 40-ish pages, short.
Actually, 20.
It's 20. So it is short for a comprehensive plan like this. But what we did was we showed, you know, the watersheds that need to be treated to protect municipal water supplies, to protect local economies, to, you know, all those factors went into prioritization. And up here, you see the red are the highest priority areas. There is actually some lighter greens that are the lowest priorities. And here we are. You know, obviously the Ruidoso areas, the Sacramento Mountains are an area of concern in this.
So, and just to one recap is that the analysis here is really primarily probability of fire and probability of debris flow in burned areas. There's some other factors in addition, but those are the two dominant ones.
So one of the things we did is we evaluated not only what information we have, but what information we needed right away. We will always have some information gaps, but some watershed studies, you know, where are, like Laura said, where are the forests at the highest risk, and the streams associated with them, and what is the expected watershed response if we do what we're talking about, if we get in and treat them at the scale that we're talking about.
So this is one of the results. Let's see if I can translate the colors. On the left is mapping of the ponderosa pine, that's the kind of olive color, and the mixed conifer forests, especially the dry mixed conifer. This is what we consider to be forests that would respond well to thinning treatments, and where you could assume and hope that the fire behavior would be different as a result. On the right then is the mapping of the debris flow risk using a model that first simulates burn of the landscape and then takes the burned areas and estimates probability of debris flow. And you can see how closely the ponderosa pine and mixed conifer correspond to the places with the high probability of debris flow. We did it in a little more detail with the U.S. Geological Survey. This was a study of the East Mountains in particular, so the Sandias and the northern part of the Manzanos. You can kind of see the grid there on the left is Albuquerque, just to orient yourself a little bit. On the left is the burn probabilities, and on the right is the probability of debris flow with a 5-year rainfall, so not a very significant rain. These are kind of expensive studies to do, but they're useful because they help us prioritize which places to treat first from the perspective of risk to property and water supplies. So now that this one is about to be published, we have kind of the wheels in motion to do more of these studies in partnership with USGS.
You know, something interesting that I found when USGS was doing this, they gave us a few model runs and said, all right, here's what we found out. Laura mentioned that, you know, it showed some differences in where debris flows may come with a 5-year rainfall event. They actually ran, simulated burning this and ran the models with a 10-year rainfall event, and everything was red. Everything was, you're gonna have a debris flow, you're gonna have some serious flooding off this if it burns. So, they actually chose the 5-year to give it some distinction. We get a big rain after any fire, everything goes. So, in talking about the study, and what was done, here's that East Mountain area that we just had blown up. The USGS is continuing to do these studies and get them published in the Jemez Mountains, in the Chalma area, and in the Sangre de Cristos right now. So those are ongoing, trying to be complete.
And in our comprehensive plan, we identified these 4 areas as focal areas and the places where the water fund, as it raises money, to prioritize its investment. We also undertook a study to look at Watershed's response to thinning. So in particular, if you think about the forest on the left, which is pretty much what the overgrown forest looks like, there's a lot of snow hung up in the treetops. And that snow is exposed to wind and sun, and it evaporates before it ever enters the water cycle. Also, in a burned area, you end up with a lot of exposure to wind and sun, and your snowpack is actually reduced. And then when it does run off, it's way flashier than it would be from, say, the thinned forest, where the canopy is open enough that the snow can actually reach the ground, but it's partially shaded so that it can last longer into the spring. So with that, we were wondering, well, what would the watershed response be if you thinned 30,000 acres a year in the Rio Grande watershed, and you did that for 20 years? So you had 600,000 acres of restored forest instead of what we have now, the overgrown forest. And I don't want to go into a lot of detail about how the study was done. Let's go forward a little bit and forward past that. And, no, back one. So we used models that were given, that we inherited, if you will, from, or borrowed from the Northern Arizona University, from a PhD student there, where she developed models to do exactly the same analysis in the Mogollon Rim for ponderosa pine. And when we ran it, you can see that there's a modest increase, whether you look at the image on the left, which is percent increase in stream flow, or you look at the image on the right, which is runoff increase in acre feet. This is for ponderosa pine. It's not for the mixed conifer, which is higher elevation, which gets more moisture to begin with, because her model isn't ready for that. She's actually working on a mixed conifer version, and sometime in the next year, we'll be able to add that to these results. And so if you go to the next one, you can see what the actual results were in terms of acre feet. And the graph on the left, on the top, shows that time elapsed since treatment is really important. So you get a big flush of water right after the treatment, and then that declines. It's a fairly steep decline for ponderosa pine because ponderosa pine is on a short fire return interval. In contrast, for mixed conifer, you might expect more like a 10 or 15 year time interval. On the bottom, it shows kind of the total increase in water, what you might expect, and you can see it's not a huge amount, but it is enough for 9,000 households, so it's not insubstantial. I can skip that.
So one of the things when we get into thinning forests, and we have this problem not just in this area but everywhere, is we can't just leave things out. We can't just treat the landscape. We can't cut the trees and leave them on the ground because that's a fuel accumulation, and it still represents a lot of that amount of fuel on the ground. I mean, there's some benefits to leaving some, but leaving it all is just too much. So what we do with this wood is actually of concern. We know that